All right, Algebra 1A students, welcome to part 2 of lesson 1-7, where we're going to be combining like terms to simplify algebraic expressions. In the last video, we talked about the distributive property and kind of what that does to help us get rid of some parentheses in expressions. And now in this video, we're going to continue on with combining like terms to simplify expressions. So we may see some distributive property in your practice problems as well. But for the most part, we're just going to be combining these like terms. Now, in an algebraic expression, a term is anything that's being added or subtracted together. Okay, so it's a number, maybe a variable, a letter like an x, maybe, or the product of a number and one or more variables. So terms are the pieces that are being added or subtracted together. So in this example here, we can see we have 4 of them. Now, a constant is a term for something with no variables, just a number. Okay, so like this 12 right here would be a constant. Okay, and a coefficient is the numerical factor of any term. So coefficient means number as well, but usually we talk about coefficients being in front of the letters or variable pieces like the 6 and the -5 and the 3 here. Okay, those are our coefficients. So we can sometimes combine these terms if they are what we call like terms. Okay, now like terms have exactly the same variable pieces. Okay, exactly the same variables. So they both have an a, or they both have an a squared, or they both have an a and a b. Okay, they have to have exactly the same variable factors. Okay, to identify like terms, compare the variable factors of the terms as shown below. So variable factors mean the letters attached to the numbers in the term. Okay, so in the first one we see a 7a and we see a -3a. Well, both of those have an a, so absolutely they are like terms. Yes. In the next example, we see a 4x squared and a 12x squared. Both of them have an x squared, so they absolutely, yes, those are like terms and we could combine them. The next example, we see 6ab and -2a. Well, the 6 has an a and a b, and the -2 only has an a, so no, those are not like terms because one has an a and a b, the other just has an a. And then the last one, we have xy squared and x squared y. So x, y squared, and x squared y. Now, xy squared really means x times y, because 2 y's multiplied together make y squared. And then x squared times y obviously would be x times y. Okay, because x times x gives us x squared. So we can see that this piece here has 2 y's multiplied with an x, and this one has 2 x's multiplied with a y. So again, no, these are not like terms because they don't have the same variable pieces. One has xy squared, the other has x squared y, not the same thing. Okay. The key for us with these like terms is we can only combine terms that are alike. Okay, we can only combine terms that are alike. Meaning I can do 7a, take away 3a, and that equals 4a. Because I had 7 and I took away 3 and now I have 4 of them. Okay? But what I can't do is say 6ab minus 2a. I can't say that that equals 4 of anything, 4 ABs or anything like that, okay? Because those are not like terms. So that is absolutely not okay. Absolutely not okay. It may seem like it's okay because you can do 6 minus 2, but they did not have the same variable pieces. They're not like terms, so that can absolutely not happen, okay? When we talk about simplifying an expression, which really is what our practice problems are about, we need to make sure that the expression that we have has no 2 terms that are alike, meaning no 2 terms that both are just an x, or no 2 terms that are both just numbers, or something like that. And it also can't have parentheses. Okay, so when we simplify, not only do we have to distribute, but we have to combine like terms as well. Okay, So we can see here an example of something that's not simplified, because not only do we have parentheses around all of this, but we have 3x right here, and we have 4x right here. Those are like terms, so we should combine those, and we need to combine them. The way we would combine these actually is first do the distributive property to get rid of the parentheses, and yes, we can do the distributive property to 3 pieces. And what we end up with then is, let's see, 2 times 3 is 6x, and then we have minus 2 times 5, which is 10, and then plus 2 times 4, which is 8x. And then I have 6x and 8x in this expression as well. 6x and a positive 8x. When I put those together, 6x and a positive 8x makes 14x. So my simplified version is 14x with a minus 10 on it. Okay? Now I would like you to try 4 practice problems for me. Okay? 4 practice problems. I got A, B, C, and D here. I want you to combine as many things as you possibly can, as many like terms as you can. Please remember, though, that when we don't see a number in front here on this y, that's a 1, so it's 3y minus 1y. So try to combine these terms if you can. If you decide you can't simplify any further, that's fine. I don't really need an explanation. You can just say, no, we can't simplify that at all. Okay? So pause the video, take a few minutes and look at A, B, C, and D here. Then come on back and I'll show you what we should get. Okay, in letter A, 3y's take away 1y, so we get 2y's. That is perfectly okay because those are like terms. They both have a y. In letter B, negative 7mn to the 4th and minus 5mn to the 4th. Well, the good news is both of those have mn to the 4th as their variable piece, mn to the 4th, so we can combine them. Negative 7 take away 5 more is actually negative 12 mn, and then we'll raise it up to the 4th power. Raise it up to the 4th power. Okay. And then in letter C, what we have to notice is that the 7 has y to the 3rd z, and there's an extra 1 y to the 3rd z right at the end here. But the middle piece is yz to the 3rd, so that's 3 z's multiplied together with 1 y, instead of 3 y's multiplied together with 1 z. So we can't actually combine with the middle piece there, but we can combine the first piece and the last piece. So 7y to the 3rd z plus another 1y to the 3rd z at the very end gives me 8 of those. 8y to the 3rd z. And then I still have this minus 6yz to the 3rd. Okay. And then finally in letter D, the answer here is no. We cannot combine anything in that expression because nothing is like terms. This has x squared, this has x to the 4th, this just has x, that just has 2, and that has xy. So absolutely not. None of those are like terms, so we cannot combine. Okay. If you have questions about combining like terms, please make a note to ask me in class tomorrow. Otherwise, that's all I have for you. Have a wonderful night.